Okay, so for this week's genetics problems, for A, it talks about a child with blood types O, Rh negative, and M, and it asks what the possible genotypes would be for the child and the parents. And for the child, for the ABO locus, I got a homozygous recessive. For the two alleles, R and Rh, I got recessive, homozygous recessive as well. And then for the MN locus, I got a homozygous dominant. And for the dad, I got heterozygous for the, so it would be like IA and then little I with it. So for the ABO locus, and then for the RH, I got homozygous dominant, or it could be heterozygous, just as long as it's with the dominant allele for the father. And then I got homozygous dominant for the MN locus. And then the mother was homozygous for both the ABO locus and the RH, and it was recessive for both. And the MN locus was, I just got heterozygous, so I got MN for that. And I just figured that all out by I just wrote it out in like proportional ways to line it all up with what the problem explained. And for B, it asks what proportion of children born to a man with a specific genotype and a woman with, again, another specific genotype would have blood types B, Rh negative, and MN. And the proportion I got was 3/32. And I also got that for C as well, which asks for the proportion of a child born to a genotype male with, and it gave the genotype of the male and the female. And so for C it was 3/32 as well. For D, it asks if a man with blood types B, Rh positive, and N says he could not be the father of a child with blood types O, Rh negative, and NM. And then it explains what blood types the mother has. And it wants to know if the man is correct on saying that he couldn't be the father. And I said no, the father isn't correct. He could potentially be the father to the child because he falls within the genotypes that are provided, and there's still a possibility that he could have the recessive trait within his genes. And then to question number 2, it talks about a walnut cone being produced, and questions A through D. I have, so it wants to know what the genotypes of the parents that produced specific phenotype ratios are for the walnut cone. And for A, it asks what the phenotype ratios would be for one walnut, one rose, one pea, and one single. And I got heterozygous for, I think it's the independent, for the rose cone. And then I got heterozygous for also the P allele, which is the pea cone, and it was crossed with homozygous recessive rose cone and a heterozygous P allele. And for B, it asks what it would be for, the phenotype would be for 3 rows to 1 single, and I got it would be a cross between both a heterozygous rose comb, and then one of them would be homozygous for P. Actually, both of them are homozygous for P. And then for C, it asks what it would be for one rose and one single. And so I got heterozygous for the rose, homozygous for the P comb for one of the parents, and then the other would be homozygous recessive for both the rose and the P comb. And then for D, it asks for what it would be for 3 walnut and 1 rose. And 3 walnut and 1 rose, I got homozygous dominant for rose, homozygous dominant for P, and then homozygous crossed with a homozygous recessive for rose and recessive for P, which P was also homozygous. Okay. And 3, it asks what the different horses, like coats, would be based on what they've given you. And for A, on number 3, it says explain the inheritance of these coat color phenotypes in horses. And I got the Palomino would be dominant over the chestnut, which would be dominant over the Cremello. And then for B, it asks to indicate the possible genotypes for Palomino, chestnut, and Cremello horses. And for B, I got, it would be Palomino could possibly be Palomino or chestnut. Chestnut could just be chestnut, and then Cremello could just be Cremello. Oh, and I forgot to say, so Palomina could also be Cremello, so it just encompasses all 3 of the horse coat colors. For 4, the blanks go, A is glycosyltransferase, and then galactose for the second blank. B is overdominance. C is incomplete penetrance. D is epistasis. E is phenylketonuria. And then F is dominant in the second space, and F is lethal. G is asking about the snail ratio, and it would be 30% homozygous dominant, 33% heterozygous, and then 40% recessive. For H, the phenotypic ratio for that one would be 40% green and 60% white. And for the final problem, 5, it just asks for the genotypes and phenotypes of the specific parents in the problem of the guinea pigs. And so that would be, for A, it would be heterozygous for black and homozygous recessive for black, which would give you the sepia color and offspring. And then for B, I got heterozygous S crossed with a heterozygous S. Bless you. And then C is, it would be a cross between like a black and a sepia one, so it would be heterozygous. And then it would be crossed with a black and a white, so it would be again heterozygous cross, and it would give you a 50-25-25 for their offspring between black, sepia, and white, like respectively. And so then finally for D, I got a heterozygous for black and white, with black being dominant to white, and then crossed with a homozygous recessive white, so that's like just like a WW. And that is what I have for my problems this week.